afternoon to you all, and thank you for joining this session. Our webinar today is on products for security for product development. The security of products released to customers is very essential to an increasing number of teams and organizations, but I would agree that not as many as it should be. It's necessary for us as a teams and organizations to defend our products against attacks. It's essential to secure our products across the entire life cycle and consider the complete product context and characteristics. So for this afternoon session, we are glad to have Anthony Sneyd, a certified offensive security professional with experience in conducting security assessments of infrastructure, networks, web applications, and systems. He believes in continuous learning, and he actively pursues certifications to broaden his knowledge. He will take us through the latest strategies and techniques for building and maintaining secure solutions and enhancing our product security practices. You are welcome, Anthony.
Thank you, Carlos. I appreciate that. Let me go ahead and share my screen and just make sure that everything looks good there. Does that look okay?
Yeah, it does. It's good.
Okay, we are going to be looking at product security from a company's perspective, which is a lot bigger world than what a malicious actor would normally see. Hello, my name is Anthony Sneyd, and I am the Managing Director of Crystal Cloud Consulting. I want to thank Carlos and Lit for inviting me to cover the topic of product security with you today. Over the past 3 years, I have helped companies secure their applications and networks through security reviews and penetration tests. Prior to that, I was an IT project manager focused mostly on IT infrastructure projects. And the beginning of my career saw me build application and email security platforms as a senior systems software engineer. So what is product security? Product security refers to the process of designing, developing, and maintaining a product in a way that protects it from potential security threats. It involves identifying potential vulnerabilities and risks in the product and implementing security measures to prevent or mitigate those risks. There are many potential consequences of insecure products. This could be loss of sensitive data. If a product is insecure, it could be exploited by attackers to steal sensitive data such as personal information, financial data, or even trade secrets. This can lead to identity theft, financial loss, and reputational damage. Disruption of services. Insecure products can be used to disrupt services, such as by launching distributed denial of service attacks that overload servers and render them unavailable. This can also cause significant financial losses for companies that rely on those services. Physical harm. In some cases, insecure products can cause physical harm to users. One example is an insecure medical device that could be used to deliver incorrect dosages of medication, causing harm or even death. Legal and regulatory consequences. Companies that produce insecure products may face legal and regulatory consequences such as fines, product recalls, and lawsuits. Insecure products can damage a company's reputation, leading to lost sales and diminished customer trust. Insecure products can be used as a foothold to attack other systems or networks. For example, an insecure Internet of Things device could be used as part of a botnet to launch attacks on other devices or networks. Imagine having 1 million vulnerable smart dishwashers connecting to the internet. Product security is critical for protecting users, companies, and the broader digital ecosystem from potential harm caused by security vulnerabilities in products. The consequences of insecure products can be significant and far-reaching. So companies that produce products must take product security seriously to protect themselves and their users from these potential consequences. Product security is the process of designing and building secure software products that can resist various types of attacks and threats. Integrating product security into the software development lifecycle involves incorporating security measures at every stage of the development process to ensure that the product is secure from the initial design all the way to the final release. Very often, we see security teams get involved at the stage right before the product is released to the customers. The conversation usually goes, we just finished this product and it needs to be security tested before it is allowed to go live. You ask, when is go live? Well, it's next week and we can't miss the deadline. What do you think happens in this case? I suspect that product received cosmetic testing. There are different methodologies for integrating product security into the SDLC. Some of the most used methodologies are threat modeling. This is a methodology used to identify potential threats and vulnerabilities that could compromise the security of the software product. The goal of threat modeling is to identify the most significant threats and then prioritize the security requirements accordingly. Secure coding practices. This methodology involves using secure coding practices to minimize the potential for vulnerabilities in the software. This includes using appropriate coding standards and guidelines, code reviews, and testing to ensure that the code is secure and free of vulnerabilities. Penetration testing. This methodology involves conducting security testing to identify vulnerabilities in the software product. You have security requirements validation. This is methodology that involves testing the software product to ensure that it meets the security requirements that were hopefully set out at the beginning of the design stage. You also have security compliance. This methodology involves ensuring that the software product meets the security compliance requirements, such as compliance with industry standards, legal requirements, and regulatory requirements. I would recommend organizations choose the appropriate methodology based on their specific needs and the requirement of their software product. Threat modeling. Threat modeling can help identify potential threats to your product. There are several ways to identify potential threats and ways to address them. You can conduct a threat modeling exercise. A threat modeling exercise would involve analyzing a product to identify potential threats and vulnerabilities. This can be done by mapping out the product's architecture, data flows, so inputs and outputs, and interactions with other systems. The exercise can also help identify potential attack vectors as well as inform security design decisions. It is crucial to stay up to date on the latest threats and vulnerabilities, including new attack techniques and emerging threats. This can be done through various sources such as security blogs, security advisories, and security research reports. Conduct security testing. This can include various types of testing, such as penetration testing, vulnerability scanning, and code review. Monitor and analyze security events to identify potential threats and vulnerabilities in real time. This can be done through various methods, such as security information and event management tools, such as SIEM, intrusion detection systems, such as IDS, and log analysis. Once potential threats have been identified, there are various ways to address them. For example, you can ensure that secure coding practices are followed throughout the software development lifecycle, implement access control mechanisms and authentication, encrypt sensitive data, regularly apply software updates and security patches, implement monitoring and incident response procedures. By identifying these potential threats and addressing them proactively, product security can be improved and the risk of security incidents can be minimized. Writing secure code is about using safe algorithms, functions, or classes. Some best practices for avoiding common vulnerabilities and writing secure code would be to validate all user input. Input validation is critical to preventing common vulnerabilities such as SQL injection and cross-site scripting. So you want to ensure that all user input is validated and use input sanitization to remove any potentially malicious content. Use secure authentication and access control to prevent unauthorized access to sensitive data or functionality. Implement secure session management to prevent session hijacking and session fixation attacks. A big one for me is following the principle of least privilege. This means that code should only have access to the resources it needs to perform its function and no more. Avoid using unsafe functions such as PHP's eval or C's sprintf functions, which can lead to buffer overflow vulnerabilities or underlying system command execution on the underlying host. Conduct code reviews to identify potential vulnerabilities, ensure that code follows secure coding practices. Other best practices you might want to consider are using a secure coding standard, such as the CERT-C coding standard or the OWASP Top 10, regularly applying software updates and security patches, using secure coding tools such as static code analysis tools, or conducting security testing such as penetration testing and vulnerability test scanning that we mentioned previously. It is important to integrate these practices into the software development lifecycle so you can ensure that security is considered at every stage of the process and not just an afterthought.